All right, in this video, we're going to be talking about how to prepare alcohols via reduction reactions. So, we are going to be reducing carbonyl groups, and that will produce primary and secondary alcohols. So, if you have a reducing reagent, you will produce either a primary or a secondary alcohol. There are three main reagents that will do this, and they will be used in different situations. So the first one is going to be sodium borohydride, or NaBH4, and this is a mild reagent, and it will only reduce ketones and aldehydes. So it is super, super important with these reagents that you keep all of this straight. So a mild reagent like sodium borohydride will only reduce ketones and aldehydes. So remember, a ketone is going to be oxygen double bonded to a carbon, and then off of that carbon are going to be two R groups. Aldehydes are going to be an oxygen double bonded to a carbon with an R group and then a hydrogen. So sodium borohydride will reduce these two things right here. The next one we have is called LAH, or lithium aluminum hydride. And this is going to be a very strong reagent, and it will reduce ketones like we see here, aldehydes like we see here, and then it will also reduce esters and carboxylic acids. So an ester looks like an oxygen double bonded to a carbon with an R group on one side, and then on the other side you have an oxygen bound to another R group. And then a carboxylic acid is going to be an oxygen double bonded to a carbon to an R group and then to a hydroxyl group. So you really need to keep these straight. Sodium hydroboride is mild. It will reduce ketones and aldehydes. LAH is strong, and it will reduce pretty much everything except for a double bond. And we're going to see here we have hydrogen catalyzed by raining nickel, or H2 over nickel, and that will reduce everything that LAH reduces plus double bonds. And that is specific to the raining nickel hydrogen catalyzed reaction. All right, so now we're going to go through some examples with NaBH4, which is our mild reducer. So remember that NaBH4 only reduces aldehydes and ketones. And so basically, NaBH4 produces a hydride ion. That's really the gist of what this does. And that hydride ion is going to come and attack the carbonyl carbon right here, and that will push these electrons up. And then we also have acid down here, and that acid will protonate this oxygen right here. So then that is going to just leave us with a primary hydroxyl group on that carbon. So same thing here. We have NaBH4, which produces a hydride ion. And I'm actually going to draw out this mechanism just so you can get the full idea of it. So that lone pair is going to come and attack the carbonyl carbon, and that will push these electrons up. And that will give you hydrogen right here. And then you're going to have an oxygen with a negative charge. And then you have the acid right here. That negative charge will come and grab one of the hydrogens of the acid, and that will protonate that, leaving you with a hydroxyl group on a secondary position. And the reason that if you use NaBH4 on an aldehyde, it will produce a primary is because this other thing right here is a hydrogen, and it just doesn't show up. Over here on the ketone, this other thing coming off of it is going to be an R group, and so that's what makes it secondary instead of primary. So we kind of just went through this, but the NaBH4 essentially provides you with a hydride ion. That hydride ion attacks the carbonyl carbon, pushing the electrons up, leaving you with an oxygen with an extra lone pair and a negative charge. and then you have water or acid, and that will protonate this oxygen, giving you in this case, the secondary alcohol. Now we're going to go through LAH. And LAH essentially works the same way, giving you a hydride ion. So if we use LAH on an aldehyde, you can see it gives you the exact same thing that NABH4 would. And then same thing with a ketone. Whether you use LAH or NABH4, it gives you a secondary alcohol. And then the mechanism for the ester and the carboxylic acid is a little bit different, and it's actually pretty cool. We're going to go through that in a second. But these will both leave you with primary alcohols. So now we're going to go through the LAH general mechanism. For aldehydes and ketones, it is identical to NABH4. But for esters and carboxylic acids, the first step is the same, but then the OR or the OH group will act as a leaving group. So the first step is the same. You have the hydride, and it will attack the carbonyl carbon and push the electrons up, giving you an oxygen with a lone pair and a negative charge. But then, this is actually pretty cool. One of the lone pairs from the oxygen will bump back down, and by that bumping back down, it is going to kick out this leaving group. So this OR right here is going to leave. And then that leaves you basically with an aldehyde again. So we started out with an ester, and then after the second step, we have an aldehyde. And then the mechanism from there is the exact same. You have more of the hydride that attacks the carbonyl carbon. That leaves you with the negative charge, which is protonated by water or acid. And then that leaves you with a primary alcohol. I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.